Welcome to lab number 5 for computer-assisted mechanisms. Today I have a couple of things for you, and hopefully they go well with the lecture. I put a lecture up today, and I intend to put another one up before the week is out. So what we're doing, two things. First thing we're going to do is on the 2015 GMC. I attempted to create a problem and then catch it with the data recorder. So you're familiar with the C recorder we used on the Explorer last week. This one is on the GMC. And what I did is I forced a failure of the Evap monitor. And it took a little bit of time. I had to drive it somewhat to make it happen, but I just loosened the gas cap, left the gas cap off, and then drove the vehicle normally, took several trips, and eventually the check engine light popped on. So I brought the recorder in and downloaded the data. So let me just share that with you here. So if you remember, the C recorder app we used last time. And I'm going to open up the file for the GMC. So that's this one right here. Here it is, the VIN for that vehicle. And, it captured 8 different trips. We'll stay with trip 8. Trip 8, we're going to look and see it starts out with the malfunction indicator light on. You know what, let's go to trip 4. Let's look at trip 4. This is the beginning of this trip. You see we have no diagnostic trouble codes. Malfunction indicator lamp status is off. If I go to the diagnostic report, yeah, I don't want to look at that. All right, back to the data stream. So we're in the correct file. Trip 4 starts out with the light off. So I did a little looking here, and right around frame 2060 is when the light comes on. So let me just advance this up to there. So you can see now we're at 2045. I'm just going to step through. So watch the number of DTCs. Right now it's at 0. Malfunction indicator lamp status is off. I'll just start stepping through. And there's 2050, 2055. And when we get to right at 2060, notice the number of DTCs changes to 1. So right there, a code set, and then in the very next frame, the malfunction indicator light popped on. So let me back that up just a little bit. Let me go back to maybe frame, somewhere around frame 2000. All right, close enough, 2004. I'm going to scroll down, and we're just going to look at one thing here, the evap vapor pressure. And you'll see that when this monitor runs, what should happen when the system is sealed and the purge is put on, the vapor pressure should drop fairly negative. So let's see if that ever happened. I'm going to hit play. We'll watch this, and I'm paying attention to what frame we're on. Right around 2060, where that code set, we'll see where we're at. So we're just mildly negative, -1/2 inch of water. Now, if you look, it started to go positive. And up here, let me back it up to 2060. There's 2060. We're negative. It went positive right there. That's at the time where this check engine light came on, right? And if we look at, let's look at purge, commanded evaporative purge, that's on 0. Let me back it up a little bit. All right, it had been purging. So I'm going to say that this is the time right here when the purge shuts off, and right away then our pressure goes from negative to a positive. That's when this monitor gave up and failed, right at frame 2060 right there. So after I caused this code to set, next thing I did was I went out and tightened the gas cap, and then went driving again. This took place over a couple of days. It actually took 2 days for that light to come on the first time. So in trip 8 down here, so we start out at frame 1. We have malfunction indicator light on. We have a DTC stored. You know, if you look, what that code is, of course, is a P0455 large leak. Right, so back to our data stream. And right around frame 826, I believe. So let me shoot forward here a little bit. So we're at frame. All right, we'll stop there. Look, we have code set, light on. Let's go down and take a look here. Our vapor pressure is way down at a -10. Let me back that up some more here. So here it is, same we saw when the code set, but as I start walking forward, what do we start to see? Give me a minute. All of a sudden, that number starts to grow, -1.43, -2, -10. Where are we? We still have a malfunction indicator lamp on, right? Keep going. -11. Up to -11 still. All of a sudden now it jumps up, -16. So what's happening here is we are starting to develop, here's 100% evaporative purge. We're starting to develop serious vapor pressure, you know, negative pressure, in other words, vacuum in the system. And so what happens when that pressure drops low? Well, that's when our monitor passes, right? So look at malfunction indicator lamp status. All of a sudden it shuts off. So what happened was our vapor pressure hit a threshold, you know, a pass threshold on this driving test or other tests, other evaporative monitors, you know, engine off natural vacuum where the vehicle's sitting. But this one here is as the vehicle's driving down the road, the test is running. The purge, if we back up a little, it was at 100%. Our pressure dropped way down. And once the monitor passed, you see the purge drops off back to normal. And shortly after that, our vapor pressure goes back as the vent opens again, and we're no longer pulling a big vacuum on the system. But at this point, the malfunction indicator lamp has gone off. Interestingly enough, though, even if I slide all the way to the end, frame 4469, we still have a diagnostic trouble code stored in the ECU. What does that mean? That means everything's normal. The light will turn off after this monitor runs and passes, but the code will stay in there for 40 warm-up cycles or until it's manually cleared or the battery's disconnected. And that's something that we're going to talk about in the lecture even more. But this lecture and lab hopefully fit together really well. When I talk about the Evap monitor, you saw it in action, right? We saw in trip 4 here at frame 2060, you know, we started, everything was fine. When we hit frame 2060, we set a code, and then the light came on in frame 2061. During that time, right, the vapor pressure never got up to that -16 that we saw when the monitor ran and passed. You know, and then we go to trip 8 where the light went off, and that was around, you know, somewhere around 826 was the frame here. So the light is still on, you know, but we watch the pressure is building, right? Purge is running, pressure is building. And as we step through that, when we hit 826, we have a nice, decent vacuum in the system. The light turned off. So here it was on, here it turned off. That's the monitor running and passing. Doesn't erase the code. So if the monitor ran and failed next time, the light would come back on, and then if it passed, the light would go off. But the code is going to stay there until this has 40 warm-up cycles without it failing. So that would reset the counter. Okay, that about does it for that vehicle. Let me stop sharing this here. And I'll be back to talk about the Explorer in a couple of minutes. So I'm back with the 2018 Ford, and I have the vehicle communications interface from the Autel. I'm going to put it inside, turn it on, and that'll enable us to go in the house. And through the Bluetooth connection, we can control the scan tool, control the vehicle, run tests if we want to, just like it was in the shop. Alright, the interface is in the car. Car's powered on. Key on, engine off. We'll go in and we can run some tests. So I've connected the Autel scan tool through an HDMI cable to my TV, and then it's connected wirelessly to the vehicle interface out in the car. So take a minute here, see if we can connect to the vehicle. Click on diagnostics. It's a Ford, and we'll let it automatically discover the car. This could take some time. Let's see if it'll read the VIN. Yes, it does. Okay. Probably could have gone into previous vehicles too, because I've been into this car before, but I decided let's just watch the whole process here. So it correctly identifies it as an Explorer with a 3.5. We'll click yes. And what we're doing right now is we're going to go into the powertrain control module and read codes. And we'll see on a Ford that we have a couple different tests available to us. First thing I should tell you, I did not warm the vehicle up before running the test. So we may find out, and I'm not sure what will happen. I know in the past I've seen if you do that, you will get codes for engine temperature or cylinder head temperature faults that are not actually faults. So we'll see what happens. Sorry this takes so long. A little challenging trying to catch the entire screen here on a camera. But, we're doing the best we can. I see in the upper corner VCI has a green check mark, and it's telling us I believe the battery voltage of the vehicle, although that seems a little bit low. Down at the bottom we have a check mark, green checks under VCI and under the vehicle, so that's telling me that we are successfully connected. I was a little concerned about the distance because it's probably 40 feet from where I'm standing out into the driveway, but I couldn't really move the entire TV and everything out there, so we'll just give this time and it will eventually come up. Okay, so we can see down here still, it's still talking to the vehicle. We still have our green checks, so we know we're still connected. We'll hit diagnosis, and I'm just going to, instead of auto scan, which can take a lot of time, I'm just going to choose the control unit, in this case the PCM. And it gives us some options here. So we're going to go to read codes, and we get several choices. Alright. First choice, key on, engine off, on demand self-test. So the term on demand implies it's going to run the test when we ask it to. So if I click that button, the vehicle is going to run through a series of tests. If I want to do the same thing with the engine running, I would pick the key on engine running on-demand self-test. Or we can just see what codes are in memory because the vehicle was driven around. Continuous self-test was running. So let me click on that first. And I do apologize for the slow communication. There's really nothing I can do about that. That's just a function of the scan tool we're using. Some are faster than others. Okay, so there's nothing in the memory, and I didn't expect to find anything in there. So we'll go ahead and we'll do the key on, engine off on demand self-test. And so it says, the vehicle must be prepared. Do not activate vehicle switches during the test. Make sure we're in park, vehicle not moving, the engine cooling fan may operate. Okay, click OK. And if we were out by the car right now, you probably would hear solenoids clicking, relays, cooling fan almost definitely coming on. You'd hear the AC compressor clutch click, vent solenoids, purge solenoids. So it's checking what it can statically, basically electrical problems. It can't check something like fuel control because obviously with the engine not running, we have no fuel control. Alright, so as I kind of expected, the cylinder head temperature sensor code. So what do you think caused that? I kind of warned you the vehicle is cold. So we have this code in here, and it's an on-demand diagnostic trouble code. And the air conditioning demand out of self-test range. So the thing here is I did not properly prepare this vehicle for the self-test. To properly prepare it for the self-test, I need to warm it up and I need to make sure that the switches in the vehicle are off. Right now, the climate control system is set to auto. So that's why we're getting that P1464. So let me back out of this. I'm going to go out, start the vehicle, warm it up, and then we'll rerun this exact same test. I thought as long as the engine is running and warming up, we might as well look at some other stuff. So I'm going to go into live data and let's find that cylinder head temperature. It's going to take a minute. And I won't make you sit here and look at it, through the entire warm-up cycle, but let's see where it's at now. I started the vehicle probably about a minute ago. It had sat overnight, and it's pretty cold right now. I didn't check the exact temperature, but it's not warm outside. Excuse me. So we'll try to look at cylinder head temperature, and then when that stops going up, we'll know we've hit operating temperature. So we're going to get a list of all our PIDs, or parameter IDs, and obviously we don't want to look at all of those. We'll just look, there are a lot. Cylinder head temperature should be, okay. So we have, degrees here. 95 degrees Fahrenheit. You can see that here, or you can see the voltage. So you can see the voltage is dropping as the temperature is going up. And we talked about this when we talked about thermistors a long time ago. So right now 98.6, doesn't have a fever, but we'll wait till that gets up, 180, 190, something like that, and then we'll come back again and take a look, and then we'll back out and go back into the self-test. I'll have to shut the vehicle off. Probably waited long enough. We're getting pretty close. 180 is, I think, what I said I wanted to get to. So let me run out and shut the car off. We'll go back to the key on, engine off. So So I have fixed the two problems that caused the failure of the self-test. Here now the air conditioning is not requested and the cylinder head temperature is probably high enough. So I'm going to go back and we're going to go back into read codes and do the key on, engine off, on demand self-test again. Hopefully those codes will no longer be there. And that'll be interesting to go back into continuous memory codes and see if those have been stored. Normally, having a cold engine is not considered a malfunction, but when you do run the key on, engine off self-test, if it sees something wrong, let's see if it stores it. So we have no fault codes now. Let's hit OK and go to our continuous memory codes and see if they're in there or not. I'm not sure what to expect, honestly. If they are, we will clear them at some point, and then it'll be interesting to see. Fords typically, when you clear the codes, they generate a P1000. Okay, so nothing in there. All right, so next thing I'm going to do is I'm going to go to the key on, engine running self-test. And what that does, you know, it enables the computer to check things that it can't check with the engine off, such as its ability to control RPM, its ability to control air and fuel mixture, its ability to control things like EGR, variable valve timing. You know, the key on, engine off test can check some electrical circuits, see if there's opens or shorts or just crazy out of range readings. But engine off, there's no oil pressure, there's nothing moving so that it can try to advance valve timing or anything like that. So let me click on this, and it's going to tell us that we're going to need to start the vehicle, but also during this test, it's going to ask us to probably step on the brake pedal, give the steering wheel a twist, and possibly turn overdrive on and off on this vehicle. And the point of that, the vehicle cannot do those things on its own. You know, it can't step on the brake for itself. So it's trying to test the brake pedal switch, the overdrive cancel switch, the power steering pressure switch. It needs your help to do that. So I'm going to go out, start the engine. It'll only take a second. So now that the engine's running, I'm going to go ahead and press OK. Unfortunately, I wish we were in the shop. We could be right next to the vehicle. You would see during this test, several things will happen. You know, one of the most noticeable will be the engine RPM will be adjusted several times. I don't know why it has to take so long to establish communication every time, since it was already established a long time ago, but it is what it is. Okay, surprisingly, it did not ask us to do any of those things. This is probably the first Ford I've ever run a test on and had it not make us step on the brake pedal, twist the steering wheel, so that's interesting. Alright, what I'm going to do now is go out and turn it off, and we're going to try erasing codes and see if it gives us a P1000. So, give me a minute there. So a P1000 is a special Ford code. Let's pick erase and see what happens. Okay, let's try reading codes. Key on, engine off, see what we get. Again with the establishing. So if there is no P1000, this part of the video will wind up on the cutting room floor. Remember now, if we do get one, it doesn't indicate, okay, nothing there. I'm going to check continuous memory real quick. If we do get a P1000, it doesn't indicate that there's a problem with the car. It would just mean that the codes have been cleared and the monitors haven't all run yet. Alright, did not put it in there. Interesting, probably because we cleared codes when we didn't really have any codes to clear. The only other thing I could probably do would be to go out and unhook the battery for a few minutes. I'm not going to bother. I'm sure you can just take my word for it. What the P1000 is if you see one. It's nothing to really worry about. So that's kind of an overview of running the self-test on a Ford. You know, the interesting things we saw, right, were when we tried to run that key on engine off self-test without preparing the vehicle properly, we had 2 diagnostic trouble codes. And if you didn't know better, you might chase after those and waste a lot of time possibly replacing parts when there's actually nothing wrong with this vehicle. So we had the cylinder head temperature and we had the air conditioning was on, and it flagged both of those as problems. It didn't give us any indication that it could be something that we did wrong when we did the test. So what I did is I warmed the vehicle up, I turned the air conditioning off, well, the whole climate control system off, and then we reran the test and it passed, no codes at all. And you saw the key on engine running on demand self-test. So 3 self-tests on the Ford, retrieving continuous memory, doing key on engine off, or doing key on engine running.